Okay, I want to do a couple of problems from your economic optimization packet. So this first one, a real estate company owns 100 apartments in Chicago. At $2,100 per month, each apartment can be rented. However, for each $75 increase in rent, there will be 2 additional vacancies. How much should the real estate company charge for rent to maximize its revenues? Complete the chart. So, in case you're not sure, the revenue is the money that they're bringing in. So, they want to maximize that. So, we need to come up, remember how to maximize a function. We have to come up first with the function, find the derivative, set it equal to 0, and verify that it's a max. So, this chart is going to help us kind of come up with the function because it's a little tricky. So, if they don't change the rent at all, so if they just leave it as is, then at 2100, then they would have all 100 apartments rented. And so their revenue would just be, you're going to multiply these. So we would have 2,100 times 100. So we would get $210,000 would be the revenue. So we're just multiplying those. If they have one increase, so that means it's going to go up by $75. So that means the rent is now $2,175. Well, then it says that there's going to be 2 additional vacancies. So now they're only going to have 98 apartments rented. So if you were to multiply these two things together, and I already did, we would get $213,150. So obviously they're going to make a little bit more. If they do 2 increases, think about what that means. That means you're going to add we're just going to add another $75 to the $2,175, and you would get $2,250. Or you could think of it as adding 2 times 75 to our original 2,100. But then there's going to be 2 more apartments that are empty. So now we only have 96 rented. If you multiply those together, you get 216,000. So that's still better off for the company. If they raise the rent 3 $75 increases, which is going to put the rent at $23.25, and we would have just 94 apartments rented. And if we multiply that, we would get $218,550 for the revenue. So again, we're still looking good. So with 4 $75 increases, puts the rent at $2,400. And that means we have 92 apartments rented. So then if you multiply that to get the revenue, you get $220,800. Now, for this next one, we're jumping, obviously, to 50 $75 increases. So you got to think about, okay, well, how do I get the amount of rent? I don't want to go through and add 75 all those times. Well, that's kind of what multiplication is for. So to get this one here, we're going to do the 2,100, and then we're going to add 50 increases of $75. So if we do that, we would get $5,850 would be the rent. Well, that's crazy expensive. The number of apartments rented. So remember, for every increase, we're gonna take away 2 apartments that are rented. So that's going to be, in this box right here, is going to be 100 minus 2 times 50. So that means we have 0 apartments rented, because nobody's going to pay that. And so then you have $0 for revenue. So now we need to come up with our expression. So then for our rent, if it's X, you can kind of see because we talked about it right here. So it's going to be 2,100 plus 75 times X, $75 for each increase, where X represents the number of increases. And then for the apartments rented, we had 100 minus 2X. And then to get our revenue, which I'm going to call R, it's going to be the rent, which is 2,100 plus 75X times 100 minus 2X. So we're going to now just multiply this out. If you FOIL it out, you will get 210,000 plus 3,300x minus 150x squared. So I multiplied that out ahead of time, so I already did that. You could check my math if you want to. So now I'm going to find the derivative, because remember, we want to maximize this. I used R for revenue. This is the revenue, and that's what I want to maximize. So I'm going to find the derivative. So R prime is 3,300 minus 300x. And now I'm going to set that equal to 0. So when I do that, I get 11 increases, because remember, X represents the number of increases we should do. So then that's going to put that, if I want 11 increases, so if you want to figure out what rent you should set it at, so we have 2,100 plus 75 times 11. And we get that the rent should be, whoops. Well, I think I remember. Don't know what happened there. 2925 is our rent. And if we wanted to figure out the number of apartments rented, we would get 78 apartments rented. And if I needed to know my revenue, because of course you'd want to know that, I'm just going to multiply those two things together, and we would get $228,150. Now, just be aware that in real life, there's other situations. If you have 100 apartments in the building and only 78 are rented, then you run other types of risks. With an empty apartment, people could, you might have vandals, and so there's other things to consider besides just the revenue. But that was what we were doing here, is just considering the revenue. And then I should make sure that you've answered the question, how much should the real estate company charge for rent to maximize its revenue? And I guess I didn't really show that it would be a max. Remember how we would do that is we would make our number line and check the 11 and make sure that that does go from positive to negative, so that that's a maximum. So you can kind of verify that. Okay, so the next problem I'd like to do is number 5, which says a small television company estimates that the cost in dollars of producing X units of a new model TV is given by C of X equals 80,000 plus 40X plus 0.2X squared. Okay, now keep in mind that's the cost of producing X TVs. Now what we're asked to find the production level that minimizes the average cost per unit, not the cost for X units, but the average cost per unit. So we're going to have to come up with an expression for our average cost per unit, not the total cost, and we want to minimize that. So we're going to complete the chart and explain, and then when we're done with this, we have to explain why the average cost to produce TVs is so great for either small or large number of units. So we'll talk about that later. So if you had 10 units, then to get this first part right here, you would just evaluate C of 10. So you'd plug in a 10 into this function, and I already did that, and you get $80,420. But then they ask you for the average cost. So you have to think about, how do I find the average cost? Well, if this is the cost of producing 10 units, then you're going to take this and divide by 10. And when you do, you get 8,042. That would be the cost per unit, which you might look at and go, oh my gosh, for a TV, for a new model TV, what's it made out of? But anyway, that's, and we'll talk about that in a minute. So if you had 100 of them, then you're going to plug in 100 into this function, okay, just this function that's given. And when you do that, you get $86,000. Let me see if I can get my calculator here. I'm just going to at least verify one of those. So if we have 80,000 plus 40 times 100 plus 0.2 times 100 squared. 86,000. Okay, so now you believe me. So then the average cost, so to get the average cost, we're going to take that and divide by 100 this time, because you divide by how many there were. So it would cost $860. Well, that's quite a difference. Okay, so we are splitting up this cost over 100 units now. If you plug in 1,000, if you evaluate C of 1,000, the C of 10 was just that first one. C of 1,000 would be $320,000. And if you divide this by 1,000 to get the average cost per unit, it would be $320. And if it were 2,000, if you plug a 2,000 into this to see the cost of producing 2,000, you would get $960,000. And if you divide this up amongst the 2,000, we get 480. And for 5,000, you would get $5,280,000. And if you divide that by 5,000, you get 1,056. So you can see now we want to minimize, because when you are in business, you want to maximize your revenue, you want to maximize your profit, but you want to minimize your cost. So that's what we're looking at, to minimize the cost. So think about what the average is. We're taking C of X and we're going to divide by X. So the cost was C of X, we're dividing by X. That means I'm taking 80,000 plus 40x plus 0.2x squared, and I'm dividing that by x. So I'm going to split this apart because it's over a common denominator. So I'm going to think of this as 80,000 over x plus, and this is just going to be 40. And then we have plus hold on. Okay, so then the x cancels, we get 0.2x. All right, now I've got, and you might want to think of this as 80,000 times x to the minus 1. I could have done that. Because now I'm going to do my average prime. I'm going to do the derivative of that. So if this was 80,000 times x to the minus 1, we're going to get negative 80,000 times x to the minus 2, or I could put that over x squared. The derivative of a constant is just 0, and the derivative here is 0.2. So if I find a common denominator, I'm going to get negative 80,000 plus 0.2x squared over x squared. So all I did there was multiply this by x squared over x squared, if you wonder. Okay, now I want to set I found the derivative. Now I have to set it equal to 0. So I'm going to put so I have 0.2x squared minus 80,000 equals 0. So then I'm going to get x squared equals, let me do the math here. So we have 80,000 divided by 0.2. So I get 400,000. And if I square root that, I get about 632.456 units if I round to 3 decimal places. So if this is the number, so this is the number of units that I should do, but then I want to find the average cost. So the average cost, if you take this and divide, I'm going to have to plug this into my cost function and then divide by that number. I did that. You might want to verify this and let me know later if I did that wrong, but I have that the average cost would be $292.98. So then when we talk about why the cost would be so much for a small amount, well, I mean, you can think about why that would be the case because you have all the equipment, all the materials, all the employees. So it would cost a lot if you don't make very many. And so the average cost per unit is going to be quite high. And then if you make too many, then you could possibly end up with a surplus of products. And if you have that too many on the shelf, then that's going to drive up the average cost per unit if you're not able to sell them. So, being able to find in business, and there's actually a whole, people that are going into business usually have to take business calculus, where it's a calculus class that's not quite doesn't get into quite all the math theorems and everything. It's kind of practical for businesses and how to do things like minimizing cost, maximizing revenue or profit, which is what you'd be interested in. So you do have some problems in your assignment in the packet to complete, and hopefully we'll have class tomorrow.